So this is what we're going to be covering incredibly in the next 2 hours. It's a big ask, but we can get a long way towards doing it. So that's me. I'm currently got a dual career, as I'll explain, but for the purposes of today, I'm at Aston University. So, give you a little bit of background to these courses. They were set up some years ago with funding from the government and also from the Royal Statistical Society. And the basic idea is to help people who are living in a digital age communicate information confidently and reliably. And also, because science is such a big source of stories today, I mean, today's biggest story, which is all over the front pages of all the newspapers, is a science story, to give people some insight who are not specialist science journalists into what is required in terms of not necessarily knowledge, but in terms of questions to ask when you're trying to communicate a science story where you may well feel out of your depth. And it's with those dual aims that these courses were set up. Now, so far, over 16 institutions have been, you're the latest, have been trained, hundreds of student journalists, and a lot of people are already in the communications business. And these are some of the organisations that have attended the sessions that we've done. So very broad in terms of coverage, background and interest in the subject. So what are we aiming to do this morning with this half of the session? Well, basically, these are the goals. So the first one is basically to give you some insight into statistical issues that pop up on science-related stories. Now, if you're from Bloomberg, you're going to be thinking, well, I don't write about cancer cures or whatever, but there are a lot of science-related stories that relate to businesses. A business's share price can be trashed overnight by a bad story about, for example, some new research on some cancer, supposedly cancer-causing compound, for example. We've seen it happen. So I'm using science-related stories in a very broad sense. So that's science and technology and health. And because dealing with science-related issues is only part of your day job, we're giving you an efficient toolkit for allowing you to assess new claims, and if you don't have the background in a specific field, at least to be able to ask the right questions of those who are responsible for the research or people you want comment from. So asking the right questions, knowing the right questions to ask other people is a very big part of being effective at science communication. And finally, we're going to be giving you some actual experience of using this toolkit, so you get some practice in how it works. Now, some of you here are from Bloomberg and are journalists, and as a result, you have a big challenge in putting into operation some of the things we're going to be telling you about good science communication practice. And that biggest obstacle is this person, the news editor, or whichever editor it is that you're working for. Because in the end of the day, you are not hired as a journalist to be omniscient about all science stories. You are not here to make a judgment about what is good or bad science. That is not what you are hired to do. And if you find yourself making that judgment without telling the news editor, if you just say, oh, I don't think this is up to it, put it in the bin, and then one of your rivals covers it the following day, you are at least in trouble, possibly got the skids under you, because there are loads of people who want journalism jobs. And if you aren't giving the news editor what they need, you can find yourself in trouble. So you are basically hired as a journalist to get good stories. But the good news is, and what we're trying to achieve today, is a balance that you can actually do both using the techniques we're going to be talking about. So, give you a little background to my career. So my original degree was in physics, and then I got out fairly quickly and got into journalism. And over the last 30 years or so, these are some of the outlets in which my writing has appeared. Firstly, as a reporter, I started on The Times. I did a couple of years with them as a specialist reporter, and then with the Sunday Telegraph for 15 years as their science correspondent, but freelanced for all these people. And that involves explaining a lot of varied science, technology, health stories in a variety of ways. And at the same time, I've had a dual career in academia. So interesting ideas I come across as a result of my journalism, I use those as a springboard for research that I do in things like earthquake prediction for this particular journal. For significance, the Royal Statistical Society's excellent quarterly magazine, highly recommended. I did a piece about why conspiracy theorists behave like they do, gave a mathematical analysis of that. So I've got several decades experience in both areas of academia and in science journalism. And over those years, I've seen what a great source of stories science is. As you know, we've got one in the news right now. I don't know what the latest is. Anybody know if that thing has bounced back off the comet? And stable. It's stable. It's sending back data, is it? Because they had some issue about the harpoon going into the comet. So that is excellent news. So, fantastic source of stories. So how do we go about reporting them? Well, essentially, anybody who's involved in science communication is fundamentally doing a translation job. So, as you all doubtless recognise, that's one of the field equations of general relativity, which has a term in it, that funny, like, it looks like an A, it's actually a capital lambda. That, if you see that in a paper like 20 years ago, you'd know that that paper was talking about the possibility that there is an anti-gravitational effect at work in the universe. It's now called dark energy. Okay, so translating from technical stuff into exciting stories for the general public is what you're about. So you're in the process of translating from jargon, technical speak into English. But the other thing you're trying to do all the time as a science, technology, health communicator is a bit of this. It's like a form of telepathy. It's actually putting yourself in the shoes of other people. So before I sit down and write a piece about the latest theory of the universe or whatever, I will stop and think, okay, what opening paragraph is going to get this story read by people who've got better things to read in whatever magazine or newspaper I'm writing for. So there's this element of putting yourself in the shoes of other people that you have to bear in mind. So that's what we're trying to do. But the bad news is, and in a way not a surprise, given how broad science is, sometimes it goes wrong. And one of the most egregious examples of this is this, the MMR vaccine story. How many people remember this or have heard of it? Right, that's great, because I was shocked when I was reading around this about how long ago it was. So I was a science correspondent on the Sunday Telegraph when this broke, and it's way back in 1998, but people are still talking about it. Now, as you can see, that title, not exactly headline grabbing, yeah. But despite that, it grabbed a lot of headlines. And there are various reasons for that. One of them is what the story, if you read the Lancet paper, it appeared in that prestigious medical journal, The Lancet, the implications of it were relevant to everybody. So, this is basically what was happening before that paper appeared. The green line, the really spiky ones, which shows a certain amount of periodicity, are the number of notifications of measles, and those are hundreds of thousands going up the side. Okay, so that's 700,000, nearly 800,000 top peak back in the sort of 50s and 60s. I remember getting measles in 1967, and it was pretty dreadful. And then around 1970, you see that line starting from the bottom axis and shooting up. That is the uptake of the vaccine, the MMR vaccine, over the years. And as you can see, it pretty much coincides with a collapse in the number of cases of measles, which is a potentially very nasty, and potentially it can be, in some rare cases, it can be fatal infection. So that was the background to it. So the measles vaccine was introduced there. The MMR vaccine was introduced, and then that paper appeared in The Lancet. And as you can see, it triggered a decline in the use of the vaccine. And if you blow up that part of the graph, you can see that it had an effect on measles cases. It essentially eradicated, and then it started going up, not to the same levels as it did before, admittedly, but 2,000 cases. These are the latest figures. And as you can see, it was trundling on quite nicely until after that paper appeared. So it's an example of a science story that went very badly wrong. Now, why did it go wrong? Well, the fundamental reason, the basic mistake that the journalists reporting on it made is to think that reputable journals always publish reputable research. Now, as someone who's been in this line of business for many years, I know that if something gets on the front page of Nature, yeah, it's okay as a story, but chances are they've put it on there because they want lots of coverage. They are much closer to being in the same line of business as newspapers than they might like to have you believe. And this put journalists in a difficult position because it appears in the Lancet, and therefore you think, well, Lancet, it's a refereed journal. All the papers that appear in it have been refereed. Who am I to argue? I'm going to go with this because it's about MMR. Lots of mothers are concerned about the MMR vaccine for their children. Yeah, this is a story, and I can always put the blame on the Lancet for publishing this thing. So that is a fundamental mistake that was made. But journalists also couldn't help their own instincts run away with them. And as the story developed over the years, and as evidence showing that this link was actually nonsense began to develop, they turned it into a one man against the establishment story, which also is a narrative logic that runs very well with the media. So we had this chap, Andrew Wakefield, at the Royal Free Hospital, and all these other experts were saying, this is nonsense. No, mothers must have their children vaccinated. Lots of finger wagging going on there. Meanwhile, this chap is saying, well, I just did this research and, I'm just quite worried about it. And I think you need to be worried about it as well. And it just had that wonderful journalistic element of one man against the establishment. But in the end, the truth will out, and it comes out in the form of hard evidence. And that wasn't pursued with anything like the vigour it should have been. But then there was also an element of a lack of understanding of what constitutes good evidence. So over the years, yeah.
That's a big point. One of the things that's interesting about that one, about MMR, is the role of journalism in dealing with Andrew Wakefield as well, though. Brian Deere did a fantastic...
years later. Yeah. Many years later. Should have been done much earlier. Yeah.
It was interesting that
Yes, and I'm glad you've made that point, because a lot of scientists and medical scientists in particular just stick it to the media on this one, and they forget that the media actually debunked Wakefield's amongst the general public, which is quite important, and that the scientific community was somewhat complicit in that this paper should never have appeared in a referee journal, end of. So the story is much fuzzier than people like to think. But so thank you for pointing that out. Another typically difficult story to deal with are stories about communicating risk. This was a story about diet soda. Now, everybody who's trying to lose weight, you know, knows that sugary drinks are bad, so they switched to diet sodas. And then some research came out a couple of years ago, basically saying that they'd found a link between diet soda and ill health. And this was very bad news, because this meant, oh, there's no escape. So it generated a lot of headlines, this story that we'll talk about in more detail shortly. And it made American TV breakfast news. And that he's the TV doctor for, I think it's ABC, and he was very good on this, and he was very sceptical, because he knew about the toolkit instinctively that we'll be going through today. So he was debunking it, and it never quite took off. How many of you have even heard of this story now? That's great. That's what I like to hear. So with this, there were a whole series of questions that he asked, and people who were sceptical of this asked. So those risk figures, yeah, they are quite scary. You know, 68% increase, this, that, and the other. How good's the evidence for it? How many people were in the study? What type of study was it? Because that has a key bearing on how reliable the evidence can be. Does it even make sense as a story, as a discovery? This is something that a lot of scientists don't pay enough attention to, that you can get a statistically significant result, but basically it's still not worth taking seriously because it's inherently implausible. And it would be nice to get the facts straight on this, because a lot of people, including me, have switched from sugary drinks to the diet variety. And the last thing we want to hear is stuff like this. And obesity is one of the big issues, health issues of the day. So it would be nice if it were right. So, perhaps the most controversial science story of them all, global warming, climate change. So this really polarises the media, polarises people. One of the fastest ways of starting a fight is to go in as a climate denier into Glastonbury concert. So, big schism, not easy to decide who's right, who's wrong. And one of the reasons for this is that the scientists involved are not prepared, well, a few are, to give definitive statements. And the ones that do, it doesn't go well for them. There was a feeling some years ago by a leading climate scientist who said that, well, you know what, I think we need to sort of make it a bit more black and white, because otherwise we won't carry people with us. And this approach has blown up. So most scientists still stick with the approach which is based on communicating uncertainty, but it does have its perils. So this is one example. One of the central concepts in seeing if there's anything in the threat from global warming is a concept called climate sensitivity. And this is the degree to which, literally, the Earth warms up on average as a result of doubling the amount of CO2, the sort of best known of the greenhouse gases, in the atmosphere. Now, the climatologists spent a lot of time modelling this to try and get this figure. And a sort of consensus view on it now is that if you double carbon dioxide levels, it will produce an increase in average global temperatures of between 1.5 degrees and 4.5 degrees and 2 degrees or greater is likely to lead to trouble. Okay, so there's the nice concrete scientific statement. So what happens to it when it gets out into the wild, into the amongst ordinary communicators and those with an agenda? So the environmentalists will look at that and they will say, scientists say it could be as much as 4.5 degrees C and only 2 degrees C is potentially really dangerous, say scientists. It's true. Meanwhile, the skeptics are saying, well, it could be as low as 1.5 degrees, according to the scientists, and you need 2 degrees for it to be, even serious, and that's what the scientists are saying. So exactly the same statement can be taken and twisted by people with agendas. That's a particularly egregious example, but I've seen worse done. I saw environmentalists pick on the output of one model that had produced a figure of 11 degrees C and said it could be as high as 11 degrees C. And this is way off. This was like an outlier. I think something went wrong with the computer that day and they should have rebooted it. But they could point to it and say, oh, some of the models are saying 11 degrees C if it does. So this is the danger that scientists face in trying to communicate uncertainty.